Hey everybody, this is Graphing Polynomials worksheet, and I'm going to go over how I think about it. And so you're given a polynomial, and if it's not in function form, of course, this is in, I'm sorry, I said function form. If it's on factored form, you want to factor it, okay? And so this has three factors, and you're going to, if it is in factored form, then it just works a little bit easier because you can see the roots. So the degree of the polynomial is the same thing as the exponent. So you could see what the equation is if you multiply all this out. And if you multiply all this out, you have x to the first, x to the second, and x to the third. So there's three x's in this, or there's a degree of 3. And, you know, if this was like squared or cubed up here like this one, then you count 3. This is 1, 2, 3, 4, 5. All right, so the second thing is the sign of the polynomial. The sign of the polynomial is located here at the front, and this is positive. And so this is positive, or, you know, you can write a plus. And this is important because this is going to determine end behavior, right? And so we had this little graph, and it's either even or odd is the degree, and then it's either positive or negative as the coefficient. So this would be 3 positive, which would be odd positive. So if you're even positive, you go like that. And if you're even negative, oh, I'm sorry, I said even. I'm getting even and odd mixed up. If you're even positive, you're like this. Think about like a parabola, and then your end behavior on negative is down, down. And then odd, so that's like a cubic. It looks like down, up, and then flipped for negative, up, down. Okay, so that means that I have to get the degree and if it's positive or negative in order to know the end behavior. The zeros with multiplicity, the zeros are based off the factors. Essentially, you can set each factor to 0 and solve, and that tells you the 0. And you can do a little shortcut. I mean, x plus 1 equals 0, solve, it's just -1. It's just the opposite, really. So you have x equals -1, and this is a multiplicity of 1. All these are going to be a multiplicity of 1. And x equals 2, multiplicity of 1. And x equals 4, multiplicity of 1. So there's my 1, 2, 3 roots, or, you know, x-intercepts. 0. Another word for 0 is x-intercept. You say roots, you know, it's where it touches the x. So then the y-intercept. Okay, the y-intercept is going to be, you're going to multiply all these together, okay? And this is really easy. There's no factor here, but it's 1 times -2 times -4. -2 times -4 is +8. So y-intercept should be 8, okay? And then the end behavior, well, the end behavior I already got from this. It's odd positive. Odd positive is down, up. So down, up. And you can write down, up too. You don't have to do it this way. All right, so on my graph, we're going to mark y equals 8. So we should touch there. And we're going to start down here. And all these multiplicity of 1 pass through. So all the multiplicity of 1 just pass through. And if it was multiplicity of 2, it would come up to the line and bounce. And if it was a multiplicity of 3, it would dance. Or in the notes it says squiggle. All right, so we have x equals -1. So maybe right there. x equals positive 2, so maybe right here and 4. Okay, all right, so this will work out. This, I mean, you can kind of see it in your head, it works out. So from some end behavior, come up, then pass, and then pass. Okay, again, what's not important is how low this dips or the shape of this. What's important is how it hits and where it hits on the x and the end behavior. And I would argue that the y-intercept is, while less important, the y-intercept is easily done, so you should just do it, okay? On this, for the y behavior, you have to multiply 3, so it's 3 times 3 times 2. And then this -1 right here, this is going to be -1 times -1 times -1. Now that's pretty easy to multiply, but let's see, this one's the same. This one is 5 times 5. So don't forget that, you know, if you have a multiplicity of 2, you have to multiply this multiple times, or twice for multiplicity of 2 in order to get the y-intercept, okay? All right, so why don't you guys try the rest of these, see if you can do them.